So now am I audible? Everybody? Yes, everybody. Am I audible now? Just give me a second. Hello, hello, hello. Hi everyone. Welcome to Vedantu JEE English. I am Diksha Kaushal, your chemistry master teacher. I hope so now I am audible to you. Yes. So guys, today we are going to, this is the day one of inorganic chemistry where we are going to complete chemical bonding and coordination chemistry concepts as well as the previous year questions. So how we are going to do that? Now, our time is less, but we have to gain the marks out of that time only. So what we are going to do, our focus will be more on the questions and the practice, but I'll tell you concept in a very short, in a very crisp manner so that you are able to understand the concept also. You also know how to apply the concepts in questions. For example, I'll start with chemical bonding. I'll start with hybridization VBT. Firstly, I'll give you a quick summary of that thing. Then we will solve the previous year questions based on that topic. Right? So topic wise, we are going to do the concept and then questions. Concept, questions, concept, question. This is how the sequence of the lecture is going to be. Okay, so are you all ready for that? Duration, it totally depends because we have a lot of questions, right? So I'll try to complete within 3 hours, right? So two big chapters, two big chunk. If you feel that I can complete that in 1 hour, so guys, that means I'm lying to you, right? So that means I'm just making a fool of you, that I'm saying that I'll complete this in 1 hour along with 100 plus questions, along with past 10 years questions, along with the concept. That's not possible, right? So time will be around 3 to 4 hours. Be prepared for that. Right? Okay. Yes, everybody, if you are okay, if you are excited for the lecture, then green hearts in the chat box so that we can start the session now onwards. Yes, bacha, everybody in the chat box. Without wasting any time, let me tell you that in chemical bonding, what are the three most important topics from where the questions are asked? So the first important topic is VBT and hybridization. So VBT and hybridization, VBT, VSEPR, right? These are same things only, right? There's very little bit difference. The combination of these things, right? VBT, VSEPR, and hybridization. And hybridization, right? The questions are asked like mostly on this topic. Mostly you will see direct question based on the structures, right? Here they will ask you the structures. They can ask you the shape. They can ask you the geometry. They can ask you the hybridization of that particular compound, right? Second important thing is MOT, that is molecular orbital theory. These are the most high priority topics from chemical bonding. Then third one is dipole moment. Third one is dipole moment. Very simple questions are asked from this one. Actually, these two chapters are very scoring chapters. If you do these two chapters, if you go through this chapter in today's lecture, only dedicatedly, if you watch this lecture today, I can guarantee that you will get your marks, right? It depends that you should watch this lecture with full 100% focus and concentration, right? After that, you have dipole moment and bond angle, and with this also I'm going to give you a simple tricks on how the questions are asked on this one, right? And last is based on hydrogen bonding, 1 to 2 question, very simple question is asked, but mainly we will focus on these two things. Then we will also see the question based on dipole moment and bond angle and hydrogen bonding, right? Okay, yes. So let us start with first is VBT, VSEPR and hybridization, right? So firstly, I'll just show you one question so that you also can be sure that yes, ma'am, these kind of questions are asked, right? Okay, so I'll show you one previous year question from shapes, hybridization and geometry. What kind of question is asked, right? This kind of question is asked. The shape of carbocation. Okay, so firstly, so I'm just giving you a very simple question here. Very simple. After that, we're going to go through the quick summary here, right? So what is going to be the answer? The shape of carbocation is, we know that carbocation is carbocation. Here you have 3 bonds, right? 1, 2, 3, and this is one positive here, right? So they are asking you the shape here. They are asking you the shape here, whether it's diagonal, pyramidal, trigonal, planar, tetrahedral, diagonal. What is the shape here? So first you have to see the sigma bonds here. How many sigma bonds plus lone pair it is having? sigma bond plus lone pair is equals to 3. And 3 corresponds to sp2 hybridization, which corresponds to trigonal planar geometry, or shape. So answer is going to be B is the correct answer. So this is a very simple question that I gave you based on shapes hybridization. Now let's jump into the concept. Like, it will take us 5 minutes to see the concept, to refresh the concept in your mind, so that you can do next 10 to 15 questions based on this particular concept. Okay, so now let us see what exactly this concept is. So firstly, let us talk about VBT, valence bond theory, right? So VBT mainly focuses on the overlapping of the orbital, right? Okay, so basically it is focusing on the overlapping of the orbital. So what it is going to tell you, I'm going to tell you the main points from where the questions are asked from the VBT, right? So first main point is, in VBT we talk about overlapping of the orbitals, like s orbital overlaps with p orbital, right? P orbital overlaps with p orbitals. So basically, because of this overlapping, we have mainly two. First thing is, what is the condition on the overlapping? There are two conditions on the overlapping. The first condition is, both the orbitals that are overlapping with each other should be half-filled orbital. That is the first condition, that they should be half-filled orbitals. Second condition is that these half-filled orbitals, right, they should have opposite spin. For example, one is clockwise, the other should be anti-clockwise. Only then they will get overlap with each other. So there should be opposite spin, opposite spin. Third condition is that whenever we are talking about, see, when we are talking about s orbital, now we have seen that from structure of atom that s orbital is spherical in shape, right? But p orbital, it is having dumbbell shape like this. It is having one positive and one negative. So the third condition is that only positive will overlap with the positive. That means if these two, see, you have this orbital, you had this orbital. When these two orbitals are combining together, right? So if this is positive, only then this overlap is possible. Otherwise, this overlap is not possible. For example, I am saying that you have, this is negative and this is positive. Now tell me, is this possible? Is the overlapping possible? No. The sign should be same, right? Only then the overlapping is possible, right? Okay. So sign of this orbital, sign should be same, right? You can just write the positive will overlap with positive, negative with negative, sign should be same. In a simple language, I am telling you, sign should be same, should be same. So these are the three conditions for the overlapping. Now let us talk about, yes ma'am, this is overlapping, but what is the benefit? What we will get out of it? So after this, next important thing is that we get two types of overlappings. One is sigma overlapping, other is pi overlapping, right? Two types of overlapping you will have. One is sigma overlapping, other is pi overlapping. So basically, sigma overlapping is head-on overlapping. When this is the orbital, they are overlapping with each other. That is called head-on overlapping, right? So this is axial overlapping, you can say, right? Or head-on overlapping, right? What about pi overlapping? This is your one orbital, this is the other orbital. When these two are overlapping with each other, right? But there is sideways overlapping. They are not, it's not like this. Overlapping, overall overlapping is happening here. No, it's like this. You have one orbital like this, other orbital like this. The overlapping will happen like this. Okay, very slight. That is why pi bond is weaker as compared to sigma bond. So here what you will see, sideways overlapping. Here you will see sideways overlapping. Sideways overlapping. So this was about the VBT, right? Now what is VSEPR, right? Ma'am, what is VSEPR? So I am just giving you the conclusion of these things which you will apply, and trust me on that, you will see that you are able to solve the questions from this particular thing, right? Now, second is, what is VSEPR? What is VSEPR? So basically, first thing is, you should know what is hybridization, right? Only then you will be able to understand VSEPR. So what is hybridization? I'm going to give you a simple trick based on that, right? So in hybridization, what we are going to see that basically hybridization is, for example, you have this s orbital, this is the p orbital, and this is one electron, one electron, one electron, one electron. It has, for example, 4 electrons here. Now this is s and this is p orbital, right? You have one s and 3 p orbitals. Now I am saying that these all, they all combine together, they all got hybridized. It's like in a bucket you are filling yellow, pink, green, blue color, and you will have a new color, and that new color is this new hybridized orbital of same energy, right? All these 4 orbitals are going to have the same energy, right? So this is one electron, one, 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 one. Now here s orbital had different energy, p orbital had different energy, but now when they are in a hybridized state, they all are having the same energy, right? They all are having the same energy. So this is the concept of hybridization. Ma'am, why it was needed? Why we thought about hybridization on the first place? So can you tell me the reason why we thought about hybridization on the first place? What was the reason behind this? Now guys, the reason was CH4 molecule, right? So if you talk about CH4 molecule, right, it is having this kind of hybridization. This is sp3 hybridized basically, right? Now, what was happening here? If I am saying that it was the same situation that we can see here, 1 electron was in S, 3 electrons was in P, right? Now, if you talk about these 4 hydrogen bonds, I am saying that hydrogen is having 1s orbital. That 1s orbital here is combining with 4 orbitals, right? That is why sigma bond is getting formed with head-on overlapping. So we are saying that 1 electron is in s orbital. That means 1 s orbital is combining. Other p orbital are combining. Other p orbital are combining. So that means the length of 3 CH should be same and 1 CH should be different. Because in 1 CH bond, you have the combination of 1s and this 2s orbital, right? But here you have the combination of 1s and 2p orbital, right? But this is not the reality. All the 4 bond lengths are same. That means there is some hybridization. That is how the concept of hybridization was given to us. That we need hybridization, only then it is possible that all the 4 CH bond lengths are same in methane. Got it? Yes, everybody? Got it? I think that's a very good revision that we are having here, right? Now, after that, now this was a core concept, right? So that you can revise that what is happening. Now I'm going to tell you what will be asked to you in the exam, right? So now here very important thing is that, ma'am, how to just tell that this is the hybridization, right? So first thing is, when your sigma plus lone pair, this you have to calculate, and here you will get the hybridization, and here you will get the hybridization. If I am saying that your sigma plus lone pair, if I am saying that sigma plus lone pair, just give me a second, it should be written here, right? If I am saying that your sigma plus lone pair is, let's say, 2, then it is sp hybridized. If it is 3, it is sp2 hybridized. If it is 4, then it is sp3 hybridized. So that was the basic concept of hybridization. Now guys, everybody tell me, is that clear to all of you or not? Is that clear to all of you or not? Yes, everybody, is that clear or not? Right? Okay, so let me write 2-3 more hybridizations here. So I don't have the space. Okay. Now, if you have, this was the basic rule, okay? This was the basic rule. Now, what if we have 5 sigma plus lone pair? So when you have 5 sigma plus lone pair, the answer will be sp3d. Right? If you have 6 sigma plus lone pair, the answer will be sp3d2. That is going to be the answer here. That is going to be the answer here. This was the concept of hybridization. Okay, got it? Now we are going to include the geometries as well that I am going to write here, right on the next page. Let me write down the geometries here. Yes. Chalo. Now I'm going to write down the geometries here on the next page. Let me just copy paste that thing here. Okay. Yes. Now, what we are going to do? I want you to tell me in the chat box that what is the hybrid, if the hybridization is SP, then what is going to be the geometry? What is going to be the geometry if the hybridization is SP? If the hybridization is SP, what is going to be the geometry? Right, I am also making one more column here for the geometry, right, for the geometry. Now, this is from where the questions are asked. Okay, this is from where the questions are asked. Now, if you talk about, you have hybridization is 2. It is going to be a linear molecule. Very good. It is going to be a linear molecule. Right. Now, I'll also show you the shapes here. Okay, I'll also show you the shapes here. If you have sp2 hybridization, that is going to be trigonal planar. Trigonal planar. Okay, if you talk about sp3 hybridization, that is going to be tetrahedral geometry. Tetrahedral geometry, right? Okay, one more thing. Okay, I'll tell you that after this table, right? Now, if you have sp3 dehybridization, it is going to be trigonal bipyramidal. 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 Okay, what about sp3d2? When you have 6 sigma plus lone pair, it is going to be octahedral. It is going to be octahedral. How many of you want to see the shapes of these hybridizations? Okay, so let me show you what exactly are these hybridizations. So firstly, let us talk about the linear. Linear, okay? Firstly, let us talk about linear. What does linear look like? Okay. Okay. Let us see what does linear look like. So basically, linear means when you have this kind of situation, okay? When you have this kind of situation, right? Okay, I'll tell you. Just give me some time. Give me some time. Okay. Firstly, I'm not involving any lone pairs here. Okay. Here I'm taking all the lone pairs to be 0. Just wait for 5 minutes. You will get to know everything, right? So this is your linear shape. Okay. This is your linear shape. Here you have A, B2 kind of molecule, right? First, you need to understand what are the angles and everything, right? What is trigonal planar? What is trigonal planar? Anybody in the chat box? What is trigonal planar? Anybody in the chat box? This is the trigonal planar shape, right? This is in one plane. You can see this is one plane only, right? It is lying on my hand, right? It is one plane and the angle is total, it is 360 degrees. So 360 divided by 3 is 120, right? So that's why we write that the angle here is 120 degree. Angle here is 120 degree. Now, the main thing is the tetrahedral, right? Usually students are confused. Usually it's not like a triangle. It's not like a triangle. It's not like a triangle. Okay, trigonal planar is, yes. If you talk about this, yes, it is like a triangle in this way. Right? In this way, if you make it, make some imaginary boundaries here. Right? Okay. Now, what is a tetrahedral shape? What is a tetrahedral shape, everybody? This is a tetrahedral shape. Anybody in the chat box, what is the angle of tetrahedral shape? Usually students are confused that, ma'am, in 3D, so we draw tetrahedral shape like this. We draw tetrahedral shape like this. Ma'am, how come all the angles are same? Arey, that is a 2D. Okay. So, let's see the figures in 3D. This is the figure in 3D. This is how tetrahedral looks like. Okay, so all the angle, if I am rotating it, all the angles are on the same side only. All the angles are on the same side. So that is your tetrahedral shape. This angle between these two, 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 all the angle is 109. Very good. 109 degree 5 minutes. Okay, 109 degree 5 minutes. Right. Okay, what is trigonal bipyramidal? What is trigonal bipyramidal? Everybody in the chat box. What is trigonal bipyramidal? Shabash, everybody. So this is your trigonal planar. This is trigonal planar, right? Here I am just going to attach two more positions here. That is called trigonal. Trigonal was for this thing. Trigonal planar was this, right? When I am attaching one atom over it, right? So this is forming a pyramid here. So it is one pyramid. If I am attaching two bonds here, it is forming two pyramid. One pyramid here, one pyramid here. So that is what is called trigonal bipyramidal, right? Now let us see what is octahedral, okay? Now let us see what is octahedral, right? Okay, let us see why octahedral. Now you have this thing, you have this thing, right? Then you have this thing, right? Then you have this thing. Now just give me a second. One more bond we need, and then you will see how does octahedral look like. This is the diagram for octahedral, right? Usually in 2D we draw it like this. We draw it like this, okay? But in reality it is like this, okay? This is in 2D, we draw it like this, but in reality also what we do, we make dotted lines here in one square, right? What does that mean? That means that these four bonds are in one plane. Okay, so these four bonds are in one plane which are at 90 degree with each other. This will help you in understanding the optical isomers as well, right? In coordination chemistry. That's why I have picked these two chapters in one part only. Right, so this is your square planar, right? This is square planar geometry. Now, when you are attaching two bonds here, right, this will become octahedral geometry. So basically on this square, when you have one perpendicular bond above and one perpendicular bond below, that is, this is not called square bipyramidal, okay? Its name is octahedral only. Though we can also call it square bipyramidal because it's a square and you have two pyramids here, but it is not called as square bipyramidal. In chemistry, it is called as octahedral geometry. Why octahedral? Ma'am, it has 6 bonds because it has 8 phases here. One triangular phase, 2 triangular phase, 3rd triangular phase, 4th triangular phase. 4 triangular phases are above, 4 triangular faces are below. 1 triangular phase, 2 triangular phase, 3rd triangular phase, 4th triangular phase. So that is why it is called octahedral geometry. Okay, so everybody in the chat box, let me know if that is clear to you or not. Everybody in the chat box, is that clear? Is that clear? Okay, so that was about the shapes and not the shapes, basically the geometries. Now we have not learned the concept of lone pair here, right? Here all the examples that you can predict will not involve any lone pair. Whenever there is lone pair, then things will change. Then the geometry is going to change. So here I'll just write sigma, right? I'm just going to write sigma, right? Reason, because whenever you will have lone pair, things will change here, right? So that's why we have VSEPR theory here, right? You have VSEPR theory, and based on the combination of VSEPR theory, the questions are asked. That is why these 3 concepts, VBT, hybridization and VSEPR, these 3 concepts should be clear in your head. I can guarantee that definitely 1 to 2 questions will be asked to you in your exam, right? Okay, so this is your VSEPR theory. This is VSEPR theory. Now let us see in VSEPR theory. Basically, we are going to talk about the repulsions of lone pairs. We know that in a bond pair, whenever you talk about a bond, in a bond, the electrons are confined in that bond. They are overlapping with each other. But when a lone pair, whenever you talk about a lone pair, it is not in a bonded state. It is free. So that is why these free electrons causes more repulsions, right? So because of the repulsions, we say that lone pair repulsions, right? Lone pair repulsions are greater as compared to lone pair bond pair, are greater as compared to bond pair repulsions, right? So now the things are going to change. Let us see how the shapes and geometries are going to change. For that, a very, very simple trick for you to remember is that shape always you will calculate only bond pairs. You will see only bond pairs, right? But with geometry, you will see bond pairs also, right? And lone pair also. This is not boiling point, guys. This is bond pair and lone pairs also. Okay, we will see both the things, right? Okay, is that clear to everybody? Now shall we move? When we will have lone pairs also, we will have bond pairs also, how the geometries are going to change. Okay, shall we see that? Yes. Okay, Sanket, don't worry. Here I am going to tell you sp3d3 also. That is also asked to you. So I'll tell you also. Basically, that is okay. So in 3D, though I can't draw that, right? It is actually like. Wait a minute. Let me show you. Wait a second. You have this kind of geometry, right? This kind of geometry you will have. Okay. It's very difficult to make and break because I don't have that much set of these bonds. That is why I have to make the bonds again and again, right? So as you can see here, right, what you can see, this was your trigonal bipyramidal, right? So here you have trigonal, right? When you have here a square bipyramidal, that is going to be your sp3d3. Okay, yes beta. Okay, basically it is going to be your pentagonal bipyramidal. Okay, right? Pentagonal bipyramidal. It is going, like, because I don't have any atom which has that many bonds, right? So I can only draw this figure in front of you. But if you just like here you have 3 bonds, right? If here you have 5 bonds and then one above and one below, right? So that is bipyramidal, and here you will form a pentagon. Okay, instead of this triangle, you will have a pentagon and then 2 pyramids, one above and below. That is called pentagon bipyramidal, not square, pentagon bipyramidal. Okay, square bipyramidal is the octahedral only, right? Okay, so now let us do this. Let us start this. Right, now, acha. Now, very simple thing I am going to do here, right? Now, first is going to be your linear, right? First is going to be your linear, okay? In a very fast manner, I am going to show you that, right? If you talk about your lone pairs, right? Here I am going to write lone pairs. Here we are going to write bond pairs. And here we are going to write the shape and the geometry, right? And the geometry, right? Okay, so let us do that. And with this, you will get 2-3 questions in your exam, right? Okay, so one, I am saying that total you have, for example, AB2 kind of molecule. The molecule is AB2 kind of molecule. You have 1 lone pair, you have 0 lone pair, you have 2 bond pair, or you have 1 lone pair, 1 bond pair. If you have 2 bond pair, that means they are talking about a linear geometry like this. That means we are talking about a linear geometry like this. This is ABB. Right, here we are talking about AB2 kind of geometry. This is having a linear shape, right? That is having sp2 hybridization. sp hybridization. Okay, so here we can also draw one more thing telling the hybridization. So this is sp. Now I want you guys to answer that in the comment section. Okay, yes, okay, yes, everybody. I want all of you to answer that in the comment section. Stop spamming, guys. Please stop spamming. Hana? Let's not spam, let's focus and let's work hard along with the other students also, right? I want to see the answers in the comment section, not unnecessary things, okay? Yes, you can clear anything if you try, right? If your basics are clear, then if you focus. But if in between the class, you're focusing on chatting, you're focusing on, rather than giving the answers, you're focusing on unnecessary things, then bacha, no, it's not possible to crack JEE. Even if you take 2 years, like you day and night, you are daily sitting in the class, but you're not focusing in the class. So what's the point of sitting in the class, right? So focus, or either you can go from the class, because that would be better for other students as well, right? So now Here we have the first thing. Second is, if you have one lone pair and one bond pair, that means AB kind of geometry. That means this is your A and this is one bond and this is one lone pair, right? So guys, here if you can see, the shape is also linear, the geometry is also linear, right? The shape is also linear, the geometry is also linear, okay? The shape is also linear, the geometry is also linear, right? So I'll just write the shape here, right? Here the diagram. Just write the diagram or the structure. You can write the structure. Why I'm writing diagram? Write the structure. Okay. So it is going to be linear and linear. Linear and linear. Right. Now, second is, then we have, when total you will have what kind of geometry? For example, you have, let's say, AB3 kind of molecule. AB3 kind of molecule. Now, I am saying that in one situation you have zero bond pair, zero lone pair, 3 bond pair, right? AB3 kind of geometry, right? Here the number of lone pair plus bond pairs, right? Okay, this is SP, this is also SP, right? This is also SP because it has one lone pair, one bond pair. That means 2 is the sigma plus lone pairs. Here it is having 3 sigma bonds, so the answer will be sp2 hybridization, right? sp2 hybridization means it is going to be trigonal planar. I have already shown you the structure, so I am not going to draw the structure here. I am just going to write it is trigonal planar, right? And it is going to be the same here. It is going to be the same here. It is going to be the same here. What about if you have AB2 kind of molecule which is having one lone pair and 2 bond pair? One lone pair and 2 bond pair. In this case, what you will see? Total you are having sp2 hybridization only because there is one lone pair and 2 bond pair. Total it is sp2 only, but the answer is going to change. Can you tell me the reason why? Can you tell me the reason why? Because you had this kind of trigonal planar when you had 3 bonds. But now you have taken one bond pair as lone pair, right? So when you are calculating the shape, when you are telling the shape is, we are not including, if I am saying this is your bond pair, this is your lone pair, if I am marking green as the lone pair, now just ignore the lone pair when you're talking about the shape. So shape is bent V shape. Okay, so shape is going to be bent V shape, but the geometry is going to be trigonal planar only, right? Because geometry will depend on the hybridization. Now, third case is if you have AB kind of molecule. If you have AB kind of molecule, in that case you will have 1 and 1, right? In that case you will have 1 and 1. Now guys, 1 and 1. No, let's talk about 2 and 1, okay? So when you have 2 lone pairs and 1 bond pair, right? Again you have 2 lone pair, 1 bond pair. That means total the hybridization is going to be sp2 only because total the number is 3. If your number is 3, then hybridization is sp2 only, right? But here the shape is going to change. No doubt the geometry is going to stay the same because geometry depends upon both the things. Now this bond pair will be replaced by one lone pair, okay? This bond pair will be replaced by one more lone pair. Now you have 2 lone pairs here. Ignore the lone pair, just see the bond pair, right? When you see the lone pair also, this is trigonal planar only, but when you ignore the lone pair, this is a linear structure. So answer will be, it is going to be a linear shape. It is going to be a linear shape. From here the questions are asked. From this shape the questions are asked. Okay. Now next is with the same thing we are going to draw other molecules as well, right? Okay. I want to see your answers in the comment section, guys. Now, for example, you are having a molecule, let's say you are having a molecule which is having which kind of geometry? 2 also we have talked about, right? Okay, let's say you have AB4 kind of structure, right? Now this is going to have, first thing is I am saying it is going to have 0 lone pair, 4 bond pair. 1 lone pair, 3 bond pair, 2 lone pair, 2 bond pair, 3 bond pair, 1 lone pair. You can just take it like this, 2 lone pair, 2 bond pair, right? That is the maximum that we want. Now, in all the cases, lone pair plus bond pair, that means sigma bond plus lone pair is going to be 4 only. So hybridization is definitely sp3 only in all the cases, right? Now the structure, geometry and shape is going to change. Let us see how the structure, geometry and shape is going to change here. Okay, yes guys, very good. In the first thing, what we have is, in the first case, what we have is tetrahedral geometry. When you have all the 4 bond pairs, so answer is going to be structure is tetrahedral, right? So structure is tetrahedral. So here I am going to write tetrahedral, right? And shape is also going to be the same, that is tetrahedral. Now I am replacing one bond pair with the lone pair, right? Geometry is going to remain the same. Now tell me, what is this shape? What is this shape? Everybody, geometry is going to remain the same. Shape will change. This is like a pyramid, isn't it? Have you seen a pyramid? It's like a pyramid only, right? It's like a pyramid only. That's why this is called what? Everybody, that is why this is called pyramidal shape. This is called pyramidal shape, right? Okay, aha, not square planar, not trigonal planar. But that's why students get confused here. See, trigonal planar is in a plane, okay? This is not in a plane. This is not having 120-degree angles, right? When you take out this bond pair as lone pair, now you have to ignore the lone pair, right? When you're ignoring it, is it in one plane? Is it in one plane? In my hand, is it having one plane? No, it is having some kind of angle more than 120, right? So what is this? This is basically your kind of pyramid, right? So yes, very good, Satvik. So answer is going to be pyramidal. Now, next what we will have, now I'm also going to replace one more bond pair with the lone pair. Now tell me, what is this shape? Everybody, what is this shape? What is this shape? It has 2 lone pairs, one lone pair here, one lone pair here, right? But I'm going to ignore that because I'm talking about shapes here, not geometries. Geometries are going to remain the same, right? So it is going to be bent V shape. It is going to be bent V shape, right? It is going to be bent V shape. Understood? Understood, guys, till here? Now, let us move to the next thing, that is AB5 kind of molecule. AB5 kind of molecule. So I am drawing it here. Either you will have 0 lone pair, 5 bond pair, 1 lone pair, 4 bond pair, 2 lone pair, 3 bond pair. Okay? Yes, 2 lone pair, 3 bond pair. Right? Okay. Chalo, we can also do one thing, that 3 lone pair, 2 bond pair. I think that is the maximum that we can have here. So now let us take a geometry which is trigonal bipyramidal, right? Okay, let us see a geometry which is trigonal bipyramidal. Okay, so this is the geometry which is trigonal bipyramidal. Okay, yes. Okay, now let us see this. Let us see this. 3 bond pairs, 1 lone pair. Where? 3 bond pair, 1 lone pair, 3 bond pair. This is 3 bond pair, 1 lone pair. No, this is 3 bond pair, 1 lone pair. Satvik, I have written it pyramidal. You only gave the answer, right? Now, this is called trigonal bipyramidal, right? So simply you will write that hybridization will always be sp3d. Hybridization is 5. 5 means sp3d. So I'm going to write sp3d. Always sigma plus lone pair is going to be 5 only. So hybridization is going to remain the same only. Hybridization will not change here. Even the structure will definitely change here. Structure I am showing you in 3D only, right? Now, geometry will always stay trigonal, bipyramidal, middle. Now, geometry will remain the same. Here, when you have 0 lone pair, geometry and shape are going to remain the same, right? But now we are talking about this is very, very important. This concept is very, very important, very, very important. Where to attach the lone pairs. So the lone pairs, shall we attach the lone pairs on this pyramidal position, on this position, or on this trigonal position? So lone pairs will be attached on this trigonal position, right? Okay, understood? Lone pairs will be attached on the trigonal position like this. Now, here I am saying that one bond pair is replaced by the lone pair. Can you tell me what kind of shape this is? What kind of shape this is? Guys, have you seen seesaw? Just replace it like this. Seesaw, seesaw, seesaw. Okay, this person here, this person here. It is seesaw shape, isn't it? This is a seesaw shape. So answer is seesaw, right? Seesaw shape. So answer will be seesaw shape, right? Okay, have you ever had any this this you will see in your parks, right? So kids are playing seesaw, right? So very common game. Now next is when you replace two lone pairs here, two bond pairs with lone pairs. So I'm going to replace only this position, right? So I'm going to take one lone pair here, right? So here it will be which kind of shape? This is what? This is what shape? Which shape you can see here? Which shape you can see? This is a T position, isn't it? T, isn't it T? Where I have written shape, I have written here shape only depends on the bond pair. Okay. Okay, Saraswati, I have written here that shape only depends on the bond pairs. Okay. Yes. Chal. Now, let us see this here. Let us see this here. It is going to be a T shape. So, just write it here. It is T shape. Okay. The next one is when you have three lone pairs. So, three lone pairs means one more lone pair, one more bond pair will be replaced by the lone pair. So, now what you will have? This shape. And what is this shape? This is nothing but it is a linear shape. So, answer is linear shape. So, answer is linear shape. Answer is linear shape. Okay, any problem here? Any problem? I can see so many comments in the comment section. Let me see if you guys have any problem here. If yes, then write it down in the comment section, right? Because after this, we are going to start with the questions related to these three concepts, right? Okay, yes. Now, the last one is your octahedral geometry, right? Acha, tell me what is the hybridization of octahedral geometry? What is the hybridization of octahedral geometry? Okay, octahedral geometry is basically AB6, AB6, right? So, what you will see here, firstly, to 0 lone pair, 6 bond pair, 1 lone pair, 5 bond pair, 2 lone pair, 4 bond pair, right? This is what we want to see. Okay, okay. Yes. Now, let us see the answer here. Always and always, a hybridization is going to be for 6. It is going to be sp3d2. That is going to be the hybridization here. Right? That is your octahedral geometry. This is the octahedral geometry, right? This is how the octahedral geometry will look like. Now, very simply, what we are going to do, we are just going to replace one bond pair with the lone pair, right? So, when I have all the bond pairs, then I'll say that the structure is octahedral, right? Structure, I am showing you here, right? So, geometry is octahedral, and shape is going to remain the same, right? When you have 0 lone pairs. Now, when I am replacing one bond pair with the lone pair, I have replaced this bond pair with the lone pair. Now, can you tell me what kind of shape this is? This is a square here, right? Basically, it is a square here, and there is one pyramid over here, right? Pyramid it is forming. So, it is called square pyramidal. Now, when we talk about here, the geometry is going to remain the same, but the shape is going to be square pyramidal. Square pyramidal, right? Now, next is when you have 4 bond pairs, that means you are also going to replace one more bond pair with the lone pair. What is this shape? What is this shape? What it is looking like? Everybody, what this is looking like? Yes, what this is looking like? Okay, Sumesh, let me write that if I have missed that. This is looking like a square planar. This is in one plane. Okay, so this is square planar. This is square planar geometry. This is square planar geometry. What I have missed in A, B, 4 molecule. Okay, in AB4 molecule, ma'am, you have missed this thing. If you have 3 lone pair and 1 bond pair. Okay, so that is basically, that was a tetrahedral geometry, right? In tetrahedral geometry, if you replace 3 bond pairs, right? If you replace 3 bond pairs, that means 3 bond pairs are replaced by the lone pair. 3 lone pairs you will have over here. So only linear geometry, linear shape will be left. 3 bond pairs are gone, right? So that means in the end you will have geometry is same, right? But the shape is going to be linear, right? The shape is going to be linear. Okay, yes, everybody got it. So that was our quick revision for hybridization, VSEPR, VBT, which is required to solve the questions. Shall we start the questions now? Everybody, are you all ready? Right? Are you all ready for the questions now? Because I have, made up your mind for that, that these are the, this is how you're going to see the questions. Okay? How many lone pair it is having, how many bond pair it is having. Based on that, you can easily tell the structures. Okay? Got it? Yes. I want to see that Josh in the chat box, that energy in the chat box, right? Okay. And I want to see the answers also. Yes, I am ready. Very good. Okay. Now, let us see that the first question on your screen is, let's be quick in questions now, okay? Let's be quick. Now, first thing they are telling is, match list 1 with list 2. Okay, you have to match this. These are all your previous year questions only, okay? So now you will see, based on these things that I have taught you only, you will see all your questions in JEE Mains, right? Now, first is they are talking about NH3, then BRF5, then you have PCl5, then you have CH4, right? So what is the catch here? The catch is to understand the lone pair and bond pair. Other things will be very simple for you. Now, if you talk about NH3, we know that nitrogen has a lone pair on it. That means it is having 3 bond pair and 1 lone pair, right? That means total it is 4, so it will be sp3 hybridization. So its geometry is going to be tetrahedral, but they are asking you the shape here, right? So shape, mostly they will ask you the shapes only, right? Otherwise, so there is nothing for JEE Mains level, right? So they will ask you the shapes only. So NH3, we know that in tetrahedral geometry, when you take out one, when you replace one bond pair with the lone pair, you have a pyramidal shape. So answer is going to be, here you have a simple pyramidal. Wait a minute. This is square pyramidal, tetrahedral, trigonal pyramidal, trigonal bipyramidal. Wait a minute. Firstly, so this is going to be your tetrahedral, right? That is D will be your second, right? What if you don't get your desired option in the match box? Then what you do? Do it like this. Now, if you talk about PCl5, PCl5 is going to be like this. PCl is going to be, you have 5 bond pairs here. No lone pair you will have. It is going to be your trigonal bipyramidal. So this is going to be 4th. So C is going to be 4th, right? What about BRF5? Bromine, that belongs to halogen. It has 7 electrons in the outermost shell, valence electrons. Out of that 7, 5 are already consumed. So that means 2 electrons are left, and these 2 electrons will be your lone pairs. So that means it will have 5 bond pairs plus 1 lone pair, right? So that means it is going to be a octahedral geometry, but in that what you will see, it will have 5 F bonds like this, right? And 1 will be the lone pair here. So it is going to be square pyramidal, right? So it is going to be square pyramidal. So we are left with trigonal pyramidal, Yes. We are left with only trigonal. Yes, that is trigonal pyramidal only. Because it was making a trigonal, है ना, triangle. Right. So answer will be this NH3 is third. Right. So answer is going to be just match this answer is going to be A3. Right. B is the correct answer. A3, B1, C4, D2. Okay. A3, B1, C4, D2. Okay, that is going to be your correct answer. Right? Okay, very good, Satvik. Very good. Now, next question is going to be on your screen, as you can see. Match list 1 with list 2. You have to match this list. Let's see how many of you can answer this. Try your best here, guys. Shape or geometry. Mostly they will ask you the shapes only. You have to, like, shape or geometry, ma'am. You to told, ma'am, shape is different, geometry is different. Sometimes shape and geometry are same also, right? So focus on shape only, right? If you talk about the simplest way is that firstly you see BRF3, right? If you talk about SF4, sulfur, it belongs to oxygen family. It has 6 electrons in the outermost shell, right? 4 bonds it is already making. That means 4 electrons are consumed, 2 electrons are left here. That means these 2 electrons are your lone pairs, right? These 2 electrons are your lone pairs. I'm talking about SF4. Sulfur belongs to oxygen family. Oxygen family has 6 valence electrons. Out of that, 4 electrons are involved in bonding with the fluorine, right? So we will take out 4. We will have 2 electrons left. That will be your lone pairs, right? So basically, we have 4 bond pairs plus we have 1 lone pair. Now, can you tell me 4 bond pair, 1 lone pair, what is the structure? Total 5. 5 means sp3d hybridization. The geometry is going to be trigonal bipyramidal, right? So out of that pyramid, what I told you, that when your geometry is trigonal bipyramidal, guys, what I told you, everybody, what I told you, you are just going to take out 1 electron, 1 bond from here. This was also the bond. You just took out that bond, right? Now it is a seesaw shape, right? So answer is going to be seesaw. For A, you have 3. For A, you have 3, right? A is 3 for this is eliminated, this is eliminated. That is only in case of this and this, right? Now, if you find out the value for B, you will get your answer, right? BRF3. BRF3 means what we have. BRF3, guys. BRF3. Bromine belongs to halogen family. Halogen is 17 group number. That means it is having 7 electrons in the valence shell, right? Now, out of that 7 electrons, 3 are already involved in bond formation, right? 7 minus 3 is 4. That means you will have 2 lone pairs. That means you have 3 bond pair plus 2 lone pair. Now, from here only, from this geometry only, I am taking out 1 more bond pair, and this is the T shape that you can see here. So, answer is bent T. Can you tell me why bent T shape? Can you tell me why bent T shape? Because here you have 1 lone pair, 1 lone pair. If I say this is your lone pair, if I am just attaching the lone pair like this, okay, if I am telling you that this is the lone pair, this green one is the lone pair, these are the bond pairs. Now, can you see that these lone pair will repel each other? VSEPR theory. They are going to repel the bond pair. Lone pair repulsion was maximum. Then you have lone pair, bond pair. That is why this is going to be slightly bent. So that is going to be bent T shape, right? So answer is going to be B is 4. B is 4. So answer is going to be C, right? Okay. So answer is going to be C, right? So C will be the correct answer. Got it? That is how by elimination you can tell the answer. But ma'am, tell us also about BRO3, right? How BRO3 is a pyramidal shape, right? So let us talk about BRO3. So guys, again, Br is having 7 electrons in the outermost shell. Out of that, basically, BRO3 has this kind of shape. Okay, it is having this kind of shape. You have double bond O, or you can also say it like this. It is having double bond O, double bond O. This is one O, right? And this is negative. This kind of shape it will form, right? That is going to be a pyramidal shape. Okay, this is not a trigonal planar. This is going to be a pyramidal shape. I'll tell you how this is going to be a pyramidal. So basically, what is happening here? Out of this Br, 7 electron, 1, 2, 3, 4, 5 electrons are already involved, and you will have 2 electrons that will be left with. That means 1 lone pair it will form. So it is having basically 1 lone pair in the extra, right? Okay, 1 lone pair in the extra it will have. That is why it is going to have tetrahedral. This is a confusing structure, okay? Students do mistake in these kind of questions, okay? Right? Okay? Yes, definitely this is useful for any competitive exam that you are preparing for that involves chemistry, right? Okay. So this is your tetrahedral. So pi bonds are not included, right? That is why this question, that is why this I'm specially explaining you this, because chances are they can give you only this in your 2025. How? Because why we are solving previous year questions? Because from here only they will pick out some example and ask you, right? Okay, chances are that, right? So you need to know the concept also, the examples also. So basically it is a tetrahedral geometry. In that tetrahedral geometry, you have how many bonds, guys? How many sigma bonds you have? Sigma bonds are 3, okay? So it's not 5 electrons. Usually students get confused. It is having 3 electrons, 3 oxygen here. So it is forming 3 electrons, right? So basically what is having that 2 electrons are present here, 2 electrons are present here, 2 electrons here, 2 here, 2 here, 2 here. So 2 more electrons are involved in pi formation, pi bond formation. That is not included in the hybridization. So that is why I'm saying it is a tetrahedral geometry. When one bond pair is replaced here, it will give you a pyramidal shape, right? So answer will be, this is your pyramidal, and this is a very, very important question, okay? Now, next is NH4. What about NH4? Right, NH4, so we all know that NH, what is NH3? NH3 is tetrahedral, will having a lone pair. When it accepts one H, then it will be NH4 positive. So basically it is a tetrahedral shape. Okay, it is a tetrahedral shape. Got it, guys? Any problem here? Any problem here, bacha? Any problem? Any student? Any problem? Am I teaching fast, or that is a good speed, or should I maintain that speed only? Right? Okay, that is clear. That is clear, right? Okay, yes. Pyramidal shape BRO3. Yes. Now, next is going to be this question. Here you have, they are simply, very simple question. Yeah, this too you all can answer. Very simple question. sp3 hybridization. That means total 4. 2, 3, 4. It is also having 4. I'll tell you one thing. This I have not told you, right? This I was telling you, I'll tell you this after some time. So basically, when you have 4 as lone pair plus bond pair, 2 things are possible. One is tetrahedral, that is sp3 hybridization. Other is square planar. Right, other is square planar directly without any lone pairs. The geometry here is square planar. I'm not saying that the shape here is square planar. I'm saying the geometry is square planar. Right, there is no lone pair involved here. Right, that is your dsp2 hybridization. Okay, if the shape is square planar, then it is an octahedral geometry. Right, if the shape is square planar, that means 2 lone pairs are attached here. The geometry is something else. But if there is no lone pair, it is simple as square planar. That means it is dsp2 hybridized. Okay. So answer is yes. Very good. So B, you are telling the answer. So A is 3. Definitely sp3 means 3. Yes, A is 3. So it is eliminated. This is eliminated. B is your square planar. Right. So B is 4. Very good. So this is also eliminated. B is the correct answer. C is 1. That is trigonal bipyramidal. D is octahedral. So B will become the correct answer. Right? Okay. Yes. Very good. Very good. Very good. Now, next we have match list 1 with list 2. Okay. You have to match this list 1 with list 2. Now, very important question. Here they are saying iodine and Cl. Now guys, first you tell me iodine has how many lone pairs? Iodine has 7 electrons, right? 7 electrons. Out of that, 1 electron is busy in making bond with the chlorine. So it will have 6 electrons. That means 3 lone pair it will have. So basically, can I say ICL will have 3 lone pairs plus 1 bond pair, right? Plus 1 bond pair. That means, can I say it can have a tetrahedral geometry and it will have a linear shape? Can I say that? It will have a linear shape, a tetrahedral geometry, guys. A tetrahedral geometry, right? A tetrahedral geometry, when you take all the bond pairs, it will become a linear shape, right? So answer will be a linear shape. So A is going to be 4. A is 4. A is 4. So B and D are eliminated. Is that clear, everyone? Is that clear? Right? Is that clear? Now we just have to see the B. Okay, just do this with the help of elimination method so that you can also save your time in the exam. Now, then you have ICl3. Now, ICl3 again, iodine is having, it belongs to halogen family. It is having, ma'am, 7 electrons, ma'am. After that, ma'am, how many bond it is forming? It is forming 3 bonds. That means 3 electrons are shared, right? So, I will subtract 3 from here. 7 minus 3, ma'am, very simple, ma'am, 4 electrons. So, it means 2 lone pairs it is having. 2 lone pairs, guys. 2 lone pairs. So, now the deal is 2 lone pairs plus you have 3 bond pairs. That means total it is 5. So, that means its geometry is trigonal bipyramidal. Its geometry is trigonal bipyramidal. Is that right or wrong? Everybody, its geometry is trigonal bipyramidal, and in trigonal bipyramidal, when you have 2 lone pairs, then the lone pairs are taken from these positions. So what will happen here, right? From this position, the lone pairs will be taken out and you will have the formation of what kind of shape? What kind of shape is formed? This is a T shape. So here B will be first. B will be first. So answer is A is the correct answer. So this also will be eliminated here, right? What about C? What about C? This too we have seen the answer. Yes, ma'am, A is the correct answer. But we need to see the question in depth. Now, what about this one? What about this? A was your linear, right? A was linear. What about ClF5? Chlorine is having how many electrons, ma'am? 7 electrons, ma'am. Okay. How many bonds it is forming? 5 sigma bond it is forming. Subtract 5 from here. You will get how many electrons? You will get 2 electrons. That means 1 lone pair. So, can I say 5 lone pairs? Sorry, 5 bond pairs plus 1 lone pair. Can you tell me, when you have 6 as the number, the geometry is octahedral. Geometry is octahedral, but there is 5 bond pair. That means 1 bond pair is removed by the lone pair. So, you will have square pyramidal geometry, right? So, answer is your square pyramidal geometry. Wait a minute. It is pyramidal simply they are saying, Pentagonal bipyramidal. Pentagonal bipyramidal will be for I75, no? So, here to they should have written square. Here the answer is square. They should have written it square pyramidal, okay? The correct answer is square pyramidal, not only pyramidal. Okay, that's the mistake of the question, okay? That's the mistake of the question. Repeat how to get the lone pairs. How to get the lone pairs? Okay, so how to get the lone pairs? Okay, so that is the main thing that I am doing in all the questions. I am just seeing that how many lone pairs it has. Okay, so how to get the lone pairs? Let's take any example. Let's take the example of ICl3, right? ICl3. This is the central atom. Firstly, you have to see how many valence electrons in the central atom. Central atom belongs to halogen. It belongs to group number 17. It will have 7 valence electron, right? So that means 7 valence electron it will have. Now you need to see how many sigma bond it is forming. So in ICl3, it is forming 3 sigma bonds. So can I say I can subtract 3 electrons from here? 7 minus 3 is what? 7 minus 3 is 4, right? So it is 4 electrons. We know that in one lone pair, you will have the 2 electrons. So in 4 electrons, we can easily say it is having 2 lone pairs. Now, these electrons, this will bond pair, so they have shown here that it is forming 3 bond pair, right? And lone pair, we have calculated 2 lone pair. That means total it is 5. Once you know the geometry, automatically you will get to know the shape. Okay? Yes. How to choose the central atom in the ICl compound? Okay. So how to choose the central atom? Basically, it is the less electronegative atom usually is the central atom, right? So here we have taken this as the I as the central atom. Okay, got it? Yes. Chalo. Now, next is, even if you do this with Cl, then also the answer is going to be remain the same only. Okay, even if you do this with Cl, answer will be same. Okay, answer will be same because those many lone pair it is going to have. Right, so answer will be same only. Yes, okay. Chalo. Now, is that clear? Is that clear? Is that clear, guys? Next is the number of species from the following that have pyramidal geometry. Right, that has pyramidal geometry and around the central atom is. The number of species from the following that have pyramidal geometry around the central atom is. Pyramidal geometry you need to see. Okay, pyramidal geometry. So in the same way, we will draw these structures as well. So you should know these structures only because these structures are a little bit complicated to draw with the help of VSEPR. So I will advise you. Now I'm going to take up those questions from where I am advising you. You should know the structures, right? It's not like you can't have those structures from these VSEPR, VBT theory, and applying that theory. Definitely you can have. But my idea is always, you should have an idea how these structures are drawn. So if you talk about SO3 molecule, right? So it is going to have this kind of structure, right? Okay, this is the structure of SO3 molecule, right? Then we are going to talk about, wait a minute, this is SO3 2 negative. Okay, because SO3 is this molecule. SO3 is having this kind of shape. This is the shape of SO3 molecule, right? This is the shape of SO3 molecule. Because sulfur tries to make, because sulfur has 6 valence electron, right? So it tries to make 6 bonds, right? So that's why it is occupying all the electrons here. It is basically, now here one more question that can arise is, it is having 12 valence electrons. It's octet, no, it is more than octet is getting complete here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So sulfur is in that category, right? So now if you talk about SO3 2 negative, this is the structure of SO3 2 negative, right? Okay, so basically when you have 2 negative, that means the oxygen will have the negative charge here, right? So oxygen will always have the negative charge whenever you have negative on that atom. So when you have SO3 2 negative, firstly to just draw a simple structure here. That how you can come to this structure is, first you need to draw a random structure. Okay, random structure is this structure, SO negative, double bond O. Now we know that 1, 2, 3, 4, 5, 6, 7, 8, right? That means 1, 2, 3, 4 electrons are used up. 4 electrons we have used from the sulfur. 1 electron is here, 1 electron here, 1 electron here, 1 electron here. 2 electrons, because sulfur belongs to oxygen family, group number 16. So 2 electrons will be the lone pair. So when you have, now from here we can say that when you have 1, 2, how many lone pair plus bond pair? It is having 3 sigma plus 1 lone pair. It is going to be 4. That is why it is sp3 hybridization. That is why it is having tetrahedral geometry. Got it? That is why it is having tetrahedral geometry. And in tetrahedral geometry, that is why we have drawn this structure. That is why we are saying that it is having pyramidal shape. Got it? Yes, everybody. How to manage the pi bonds here, right? How to manage the pi bonds. Now, let us see for SO Sorry,